We've been using this page as a good outline of all the different lipids we're interested in talking about, and we're almost done. We've just finished up a couple of compounds, or a couple of different classes, steroids. In particular, we talked about cholesterol. Now, notice we have other types of things like hormones, sex hormones and corticosteroids. I want to just say right off the bat here that we're probably going to just not talk about bile salts, so we'll cross that one off. We also talked about how those are in the polar or amphipathic area, but we have cholesterol esters down here, which are in the nonpolar lipid area, along with triacylglycerols. All I really want to talk about this time is the other steroids and this compound called terpenes. So let's turn the page over to the one right after where we did cholesterol. And before we talk about terpenes, let's go down and talk about other types of steroids. I'm going to call this section steroid hormones, because what we can see here is two molecules that have the standard steroid core, A, B, stagger to C, and then D with 5 carbons, A, B, C, D. And as promised, what we can do is have different attachments to the steroid core and get different molecules and different functions. This molecule is called testosterone. And you probably know that that is a sex hormone for male specific sex characteristics, and I could show you the estradiol or estrogen and show you that it's very similar. And what we can see about this molecule, in fact it's true of both of these molecules, is that these are not amphipathic. I call these slightly polar. They're not strongly polar. In fact, they're very insoluble in water generally, but they do have a few polar groups, and having a weakly polar group on each end, it takes it away from being amphipathic. These are not membrane molecules. These travel in the blood, and they need to be somewhat polar to do that because the blood is an aqueous-based area. The other molecule over here is also a hormone. It's not estrogen, though. This one is called cortisone. And it is also slightly polar and travels in the blood. And the purpose of this molecule is to be anti-inflammatory. Very powerful anti-inflammatory. And you can use it if you're having inflammation in a wounded knee or something like that, if you're a football player, or if you have an immune response to something you're allergic to, like poison ivy. You can use cortisone to knock that immune response down. Perhaps you've heard of NSAIDs, or non-steroidal anti-inflammatory drugs like Tylenol and Motrin and things like that. Well, those are over the counter because they're weak. This type of steroidal anti-inflammatory is very powerful. Prednisone is another one that's used often. Very powerful. You can't take it for very long because it really knocks the immune system down. We should probably make a note that testosterone and estrogen are sex characteristic hormones. We said it. Let's just make a note of it. Okay, that's good enough for the steroid hormones. Like I say, there's hundreds of them in your body, but we're just giving you some examples to go by. Let's go to the top of the page and talk about what we call, let's cross this out. This really should be called terpenes. Terpenes are a class of lipids, and they are lipids because they're typically all nonpolar, but they are not created from any of the other components that we've talked about. We don't have fatty acids, we don't have glycerol, we don't have head groups and things like that. In fact, these are going to be made from isoprenes. That's why I had that written on there. Isoprene is the subunit, and isoprenes are 5 carbons, They're branched, and they are unsaturated, meaning they have double bonds. So this is very different than fatty acids, which are linear and not composed of 5 carbon units, but rather 2 carbon units. They tend to be even numbered. And if we take isoprenes and string them together, we get molecules called terpenes. And there's literally thousands, if not hundreds of thousands of these in nature. And they tend to be things like pheromones for insects. They tend to be plant hormones or plant signaling molecules, things like that. And so every plant has its own variety of different molecules. Some of them are pigments, and we have one of those shown right here. This is called beta carotene. And if you were to count the number of carbons up, you would find that there are a multiple of 5. And what we can also see is pretty much you can see the presence of these isoprene units like that. You can see them all up and down here, those 5 carbon units. And sometimes they get modified. We make them into rings. We take away some double bonds or add some double bonds. You just get a tremendous variety of compounds. One other function that they have is to be vitamins, lipid-soluble vitamins. Let's make a note of that. Lipid-soluble vitamins are things like vitamin A, vitamin E, and vitamin K. These are all going to be derived from isoprene 5-carbon units, and these are going to be slightly different than the water-soluble vitamins we'll talk about later, like riboflavin, niacin, pyridoxal, things like that. So that's good enough, just sewing up some loose ends here in the variety of lipid molecules that exist in nature.